All right, guys, welcome back. Almost done our derivatives unit. All right, next topic is called implicit differentiation. Okay, so guys, the tricky part over here, guys, is well, not tricky part here, guys, but like I think it's very obvious here. I don't know if we've seen this notation yet either, but if I say d dx of x, this means what is the derivative with respect to x of x? Well, the derivative of x is 1. Okay, we've talked about that earlier on, because this is like x to the 1, so it comes down, our derivative of x is 1. Okay, well, different question. What is the derivative of x, the derivative with respect to x of y? Well, this answer is dy dx. Okay, so as far as like, if y is a function of x, well, we don't know what the exact derivative is going to be, so we're just going to call this guy dy dx over here. So this is kind of the first part that we need to be able to kind of get with this idea over here, guys. The derivative of x is 1, but the derivative with respect to x of y is dy dx. Okay. So if I have this guy over here, what is the derivative of y equals f of x to the 5th? Okay. Well, hopefully, guys, we recognize that this is a chain rule type question. Okay. So this is something to the 5th. So my derivative would be 5 f of x to the 4th times the derivative of the inside, which is going to be f prime of x. Okay, so the derivative of f is f prime of x. Like that. So we're just going to write this like this. Okay. Here's where it gets a little bit trickier here, guys. X squared plus y squared equals 25. So this is the equation of a circle with radius 5 here. What we're going to do over here is we're going to use so we're going to take the derivative of both sides of this equation. Okay, so what we're going to do is we're going to take the derivative of x squared plus y squared on the left-hand side, and we're going to take the derivative of 25 as well. Okay. Now, what's the derivative of x squared? Derivative of x squared is 2x. Now, what I'm going to put in brackets here, guys, I'm going to put a 1, okay? Because if the 2 comes down, it becomes 2x to the 1, but then the derivative of x is 1 over here, okay? So this, guys, this is a very trivial thing over here that we just don't need to write over here, but it's going to make more sense about what we're going to do in the next step over here. If I have y squared, the derivative of y squared is going to be 2y. But then, what's the derivative with respect to x of y? Well, it's going to be dy dx. And guys, this is the most confusing part about this lesson over here. So why do we have this? Okay. Well, if I look at it this way, the 2 comes down, it becomes 2x. The derivative of x is 1. That's just chain rule. Over here, the 2 comes down, it becomes 2y. But the derivative with respect to x of y is not 1. It's equal to dy dx. The derivative with respect to x of 25 is 0. Okay. Now, we just need to be able to solve for dy dx. So I'm going to subtract 2x from both sides. Divide by 2y. The 2's cancel out. And we get this guy over here. Okay, so what's different about questions like this is that normally, guys, our derivative was always in terms of x, but in this case, our derivative is in terms of an x and a y, and that's okay. Okay, so we're allowed to have a derivative in terms of x and y as well. Example 4, what's the equation of the line tangent to the circle at the point -4 and -3? Now, we already, from our previous example, it was -x over y. Okay, so how do we use this derivative now to figure out the slope? Well, we have this point over here. So here's why I'm going to do this notation here. dy dx at -4, -3 is equal to -4 over -3. That means this guy over here is going to have a slope of -4/3. Okay, so from here, if I just go down 4, 1, 2, 3, 4, 1, 2, 3 to this guy over here, my line should look like this. Okay, so what's this equation going to be? I'm just going to put this guy into slope, point slope form. Y plus 3 equals negative 4/3 times x plus 4. And this is the equation of the line that's going to be tangent to this circle at the point negative 4, negative 3. Okay. All right, similar idea here, guys. Just a bit more complicated. Determine the dy dx of 2x to the fifth plus x to the fourth y plus y to the fifth equals 36. Okay. All right, so how is this going to work here? We have we're going to take the derivative of both sides of the equation. Okay. What's the derivative of 2x to the fifth? Well, it's 10x to the fourth. On this case, x to the fourth y, we have to treat this as two functions, x to the fourth and then y. So we have to use product rule on this guy here. So I go first, second prime, x to the fourth, and the derivative of y is dy dx plus second first prime, y times 4x cubed. Okay, so there's my product rule for x to the fourth times y. Derivative of y to the fifth is 5y to the fourth times dy dx, because I have to use chain rule on that guy, equals 0. All right, so now, how do we get dy dx by itself? Well, I have a dy dx here and here, and these two terms here do not have a dy dx. So I can keep all my derivatives on one side and everything else to the other side. So what I have so far is I have x to the fourth dy dx plus 5y to the fourth dy dx equals negative 10x to the fourth minus 4x cubed y. Just brought this guy over here. And now what we're going to do is we have a common factor of dy dx on the left-hand side. So I'm going to factor this guy out. And now I'm going to divide. All right, a lot of work to be able to get this guy over here, but this is how this guy works. All right, find dy dx if 2x over x plus y equals y. So again, we take the derivative of both sides. Now, when I take the derivative of the left-hand side here, I have to use quotient rule. So quotient rule is bottom top prime minus top bottom prime. Derivative of x plus 1 is 1 plus dy dx equals derivative of y is dy dx like this. Okay, I'm going to do a bit of distributing here. Okay, and then those two x's cancel out. So I'm going to bring the negative 2x dy dx over to the other side of the equation, and now I have a common factor of dy dx. And now I'm going to divide by 1 plus 2x. here is our derivative in terms of x and y for this guy right here.